Afternoon to all. Today we have discussed the topic regarding the antenna and wave propagation. Basically, we have solved the number of MCQ in this particular lecture related to antenna and fundamental concept of antenna, antenna parameters and definitions, and other concept of antenna, which is known as loop antenna. So basically three chapters we have discussed in this particular video lecture. So try to understand this particular point. So first of all, I have given my introduction in brief way. In whiteboard, I have write my the name. First of all, joining Fundame department, electronics, communication, electronics and communication, college, DVP Engineering College, DVP Engineering College, lecture content, antenna parameter, plus loop antenna, plus MCQ solution. Loop antenna only MCQ solution. And another important point that can be discussed here, it is known as radiation electric dipole. Bracket in bracket, fundamental concepts only. Fundamental concepts only. So we have discussed this particular point in this particular lecture. So we have started the topic related to antenna. First of all, antenna is what? It can be act as a sensor of the electromagnetic wave. It can be act as a sensor of the electromagnetic wave, or or it can be act as a impedance matching device. Impedance matching device means what? It it matches the impedance between the transmitting antenna to free space and free space to receiver. So it is the fundamental concept regarding the antenna and wave propagation. Regarding the antenna and wave propagation, it is the fundamental concept. Assume that this is transmitting antenna. Assume that this is X. Here, assume that it is known as RX. Receiver antenna. It is known as receiver antenna. It is known as transmitting antenna. It is known as receiver antenna. Sensor of the electromagnetic wave means what? It matches the impedance between transmitting antenna to free space. See here, it is known as free space. I will write here, it is known as free space. Free space means what? What is the impedance of free space according to electromagnet? It is known as 377 ohm. So transmitting antenna impedance is 377 ohm. If met with free space, then power is transferred from transmitter to receiver, and receiver also able to receive the power if impedance is 377 ohm. With respect to free space, if medium is changed, then depends on different medium, impedance is different. So it can be act as a antenna can be act as a sensor of the electromagnetic wave. Antenna can be act as a impedance matching devices. So it is the basically concept regarding the fundamental concept of antenna. Now I have switched over the point which is known as antenna parameter and affiliation. See this particular PDF. I have already given so many times in your WhatsApp or mail ID specifically for EC student, VVP student. L di by dt is equal to q dv by dt is equal to qa equal to q d2z by dt2. It is the fundamental equation of relation. It is the fundamental equation of relation. See this particular theory. See this. First of all, first theory, what is the meaning of antenna? Compare antenna and transmission line. So antenna can be act as a metallic device or conductor material which is used to convert electrical signal into electromagnetic wave, and receiver side it is used to convert electro EM wave into electric signal. It is very useful for MCQ. Please prepare that. It is very useful useful for MCQ. I have highlighted with I have highlighted with this. This is known as this is most useful for MCQ. So be prepared this very carefully. Now next point, antenna is the sensor of the electromagnetic wave. Also see this, it is very useful for MCQ. Antenna can be act as a sensor of electromagnetic wave. Antenna can be act as an impedance matching device. If resistance is perfect, then maximum power can be transferred from transmitter to receiver. Now antenna can be act as a transducer. So it is known as also concept of fundamental concept of antenna. Now, how antenna can be able to transmit and receive the electromagnetic wave? Now, according to MCQ, this is, see, if this wire is straight, if this wire is straight, if this wire is straight, then it is not able to receive the electromagnetic wave. Straight wire means what? It charge can be traveled within it with uniform velocity. That's why electromagnetic wave cannot be able to radiate. So electric charge radiate at certain condition only. If charge is stationary, see this. If charge is stationary, so current is not created. So there is no amount of radiation that can be present. Let us consider that pulse of electric charge move with move with straight line in the conductor. See this straight line in the conductor at which current can be flow. But remember that point, it is known as AC current, not DC current. So if AC current is passed, so I equal to Q dq by dt. It is the fundamental relation. Dz by dt means what? Velocity that can be changed with respect to time, or distance that can be changed with respect to time. So dz by dt, and or length, here we can multiply with length. Don't do anything. Dz by dt means what? It can be said as meter per second. So ql into v, so total charge distributed on of the pulse on the wire, q equal to integration rho l dl. So l di by dt, L di by dt is equal to q dv by dt. Why? Because applied the concept of differentiation on both sides. So here it is known as acceleration. Here it is known as velocity that can be changed with respect to time. So it is known as acceleration. So it is considered as a d2z upon dt2. It is considered as a d2z upon dt2. Why it is considered as a d2z upon dt2? Because see this equation. See this equation, I have marked with circle. Compare with this equation. Compare this equation, circle equation, with dz by dt. With dz by dt. So it can be considered as a d2z by dt2. So it is the first MCQ or second MCQ in our question bank. What is the fundamental equation of current that can be able to radiate the electromagnetic wave? If this equation is satisfied, then electromagnetic wave able to radiate the current from the wire. Remember that point. Electromagnetic wave radiate the current from the wire if this equation is satisfied. If Maxwell equation, what is the difference between Maxwell equation and this equation? Maxwell equation, it is related to different media. If electromagnetic wave from travel from one medium to another medium, at that time Maxwell equation can be useful. But if electromagnetic wave, if electromagnetic wave travel in the same wire, at that time it is not at that time electromagnetic wave able to radiate the power based on this equation only. Maxwell equation is used for the different media. Remember that point. If different media is not present, only single media is present, at that time this equation is used. Now EM wave produced due to moving charge with acceleration and wire is curved. Wire is curved means what? Consider this is the wire. If wire it is straight, consider this is the straight wire, then electromagnetic wave cannot be able to radiate. Electromagnetic wave cannot be able to radiate, but wire can be considered as a one type of curve. See this is the curve. This is the curve. So at that time, electromagnetic wave can be radiated from this. So it is considered as a electromagnetic wave radiation if charge is if a wire is curved type of wire. Now, now this is alternate source, plus minus minus plus plus minus plus minus. So due to plus minus, electric field generated due to the source travel to the positive charge to negative charge, and it is responsible for the generation of closed loop. It is purely theoretical concept. I think in this particular thing, MCQ will be not asked any type of, but here see this. This is the most important. At t equal to t by 2, if electromagnetic wave can be traveled from transmitter to receiver, consider this is the transmitter, consider this is the receiver. If electromagnetic wave can be traveled like that from this source, see here t equal to t by 2. At t equal to t by 2, consider this is the source of electromagnetic wave. Consider this type of wave can be applied to antenna. So in positive cycle, wave can be like that. Similarly, for negative cycle, I have sketched the waveform related to negative cycle. If negative cycle, then waveform can be like that. See this. This is the waveform. This is the waveform. Waveform can be like that. See this. This is the waveform. Waveform can be like that, and t equal to 0. At t equal to 0, waveform creates the closed loop. Waveform create the closed loop. Closed loop at t equal to 0 second. So it is considered as a one type of closed loop system at t equal to 0 second. Now now comparison between antenna and transmission line. It is used to transmission with antenna or antenna with receiver. It connects the transmission line with free space. It is considered as an antenna. So it is known as the difference between transmitter antenna and transmitting antenna and receiver. It connects the transmission line with free space. Now transmission line I avoided to radiate wave. Antenna are intended to radiate the wave. So it is the difference between transmission line and antenna. Please prepare very carefully. Directly MCQ will be asked. Whenever I have solved the MCQ at that time, this MCQ can be asked. Antenna radiate. પછી filling the blanks હશે અને કીધું હશે ખાલી જગ્યા wave. Antenna radiates filling the blanks waves. So what is the answer? Antenna radiates the spherical waveform. So It is the concept of difference between transmission line and antenna. Now it is known as radio communication link with transmitting and receiving antenna. It is source, it is transmitting antenna, it is receiving antenna. See this. It is the pure it is the pure component of radio communication link, transmission line, transmitting antenna, plane wave transmission line, and receiver. It is the concept of radio communication link. Now, see this, this is the different types of antenna. If it is the different types of antenna, wire antenna, dipole loop helix, aperture antenna, horn and slot. Remember that point. Based on that classification of antenna, there is the lots of MCQ questions that can be asked in the examination. See this question asked like that: classify aperture antenna. Option is given as first option horn, second option slot, C option AB both, D option dipole. So what is the correct answer? Correct answer is C, horn and slot. It is the classified as a aperture antenna. So it is considered as a classification of antenna. It is the classification of antenna, or explain the different types of antenna. This, see, this is you have to direct remember. There is nothing explanation regarding that. Why it is known as aperture antenna? Why is known as aperture antenna? Aperture means what? Physical amount of area. So horn and slot antenna had specific area. Also parabolic reflector antenna, it is types of aperture antenna. Now print antenna. Printed antenna means what? Any type of material that can be established into any particular ways. See this, I have explained here. See this rectangular strip. Now I have cut the rectangular strip in specific path. See this, this is the path at which I have cut the rectangular strip. See this. So it is considered as a microstrip patch antenna. That type of antenna, it can be considered as a printed antenna. Now, now low gain antenna, high gain antenna, and medium gain antenna. What is the meaning of that? What is the meaning of that? Low gain antenna, high gain antenna, middle gain and medium gain antenna. This antenna contains the highest gain. This antenna means what? Parabolic reflector type of antenna. Next, horn antenna. Horn antenna, it is known as medium gain type of antenna, and low gain type of antenna means what? Dipole loop, that type of antenna. Beam shape, omnidirectional antenna, pencil beam and fan beam. It is considered as a beam shape. Now see, this is the symbol of the different antenna. Now next topic, which is known as antenna parameter and definition. Antenna parameter and definition. Now based on this particular chapter, there are the lots of MCQ that can be asked in the examination. I have also shared the link in the Google Classroom, sandfoundry.in, or we can say other electronics.com, at which you will able to identify the MCQ related to antenna. So beam area, radiation pattern of field and power pattern, half power beamwidth, personal beamwidth, polarization, radiation intensity, beam efficiency, directivity, radiation resistance, resolution, antenna aperture, physical aperture, effective aperture, freeze transmission formula, very important for MCQ. All the content which can be established here in the chapter number 2 according to GQ syllabus. It is very important for MCQ. Let us start with first MCQ. See this, which type of MCQ that can be asked. First MCQ I have shared with you, which is known as radiation pattern. Radiation pattern. What is the types of radiation pattern? First MCQ. What is the types of radiation pattern? Main type of radiation pattern. So what is the different types of radiation pattern? There are the total three type of radiation pattern. Three type means what? What is the first type? Isotropic radiator, omnidirectional, omnidirectional radiation pattern, directional radiation pattern. Now, first of all, what is the meaning of radiation pattern? Ability of antenna to radiate the power. Ability of antenna to radiate the power, and it can be represented graphically. It can be represented graphically. So it is known as radiation pattern. See this. Consider this is the transmitting antenna. Consider this is the receiver antenna. Consider this is the transmitting antenna. Consider this is the receiver antenna. Now, now power radiate from antenna. It can be it can be represent graphically. It is known as radiation pattern. Power radiated from antenna that can be represented graphically. It is known as radiation pattern. Now, what are the types of radiation pattern? Three types of radiation pattern. Now, out of three types, one of the first type of radiation pattern, which is known as isotropic antenna. Isotropic antenna. See this is the radiation pattern definition. It is also also asked in terms of MCQ. What is the meaning of radiation pattern? See this type of MCQ that can be asked. Now, isotropic antenna. Isotropic antenna. It is considered as a reference antenna. It is considered as a reference antenna, and power radiate through this antenna is considered as a reference antenna. Reference antenna and power radiate in all direction. Power radiates in all direction means what? This type of pattern we can get due to isotropic antenna. Isotropic antenna, it can be act as a reference antenna. Power radiated through antenna is all direction, is present in all direction. It can be considered as a ideal antenna. Can be considered as a ideal antenna. So it is known as isotropic radiator. Now, second, which is known as omnidirectional antenna. Or in MCQ, question asks like that: what is the function of isotropic radiator? Option A, it radiates power equally in all direction. Option B, it can be considered as a reference antenna. Option C, it can be considered as an ideal antenna. Option D, ABC all. At that time, answer is ABC all. Now, see this. This is known as directional antenna. Directional antenna means what? Radiate the power, radiate the power in specific direction. Radiate the power in specific direction. Now, See this. Radiate the power in specific direction. See this. It is known as radiation pattern. There are also two types of radiation pattern, other two types. I will explain this. It is known as field pattern and power pattern. With reference to antenna, it is considered as a three type of isotropic radiator, second omnidirectional, third directional. But what are the types of pattern? Field pattern and power pattern. So in MCQ, at that time you have write three types of pattern, not two. Remember that one. So E of theta, so it can be considered as a dotted line. Dotted line indicate null. Null means what? Amount of radiation is 0 degree. Now see, it is considered as a major lobe. It is considered as a major lobe. Power radiated in maximum direction. Now see, it is considered as a minor lobe. It is considered as a minor lobe. Power radiated in different direction. So what is the difference between major lobe and minor lobe? Suppose consider this is the area of crystal hole, and if you want to deliver the power in the surrounding area, so it can be considered as a major lobe. But except major lobe, whatever power that can be radiated, see here, whatever power that can be radiated, it is known as backlog. It is known as backlog. Backlog means what? Consider this is the crystal mold tower. So backlog means what? Behind the crystal mold, whatever area that can be present, it can be considered as a backlog. Remember that point, backlog and side lobe, that can be 180-degree phase shift with respect to each other. Now, based on this radiation pattern, whatever power measured is power measured in decimal. Power measured in decimal, so it can be measured in decimal value. Now, there is the four type of lobe that can be present in the radiation pattern. First, major lobe, minor lobe, back lobe, side lobe. There is the four types of pattern. There is the four type of lobe that can be present. So please prepare how many type of lobe that can be present in the radiation pattern. That question can be also asked in the examination. Now see this is the front direction of power, and this is the back direction of power. Obviously, back direction of power is comparatively low compared to front direction. So, what is the meaning of FBR, front to back ratio, equal to power radiate in forward direction divided by power radiate in backward direction. Power radiated in forward direction divided by power radiated in backward direction. So it is considered as a front to back ratio, FBR. So it is considered as a FBR, front to back ratio. So it can be considered as a one type of MCQ question also. Whatever MCQ that asked in the many different way that I have discussed in this particular video lecture. So please carefully prepare this very carefully. Now, one of the different concepts, radiation pattern. How to sketch radiation pattern? Take the different angles, 0, 30, 60, 90, 150, 120, 150. This is the practical approach. 180, 210, 240, 270. Put the value. Sine 00, sine 30.5, sine 60.86, sine 91, sine 120.86, sine 150.5. So based on that, you have sketched the radiation pattern. This is the radiation pattern. So two types of basic pattern, field pattern and power pattern, and types of radiation pattern, omnidirectional, isotropic, and bidirectional. Already explained. Directional pattern means what? Radiate the power in specific in direction. Null means what? 0 degree radiation. Four type of lobe: major lobe, Major lobe means what? Power radiated in maximum direction. Side lobe means what? Any direction with respect to major lobe. Backlog, already discussed. Now see omnidirectional. Omnidirectional means what? See, this is the graph. See, this is the graph of omnidirectional. Perpendicular to the axis. Perpendicular to the axis at which power can be radiated. Power can be radiated through the perpendicular of the axis. It is known as omnidirectional antenna. It is known as omnidirectional antenna. See this. Antenna having non-directional, essentially non-directional pattern in given plane, non-directional pattern in given plane, and directional pattern in orthogonal plane. So it can be considered as the omnidirectional antenna. It can be considered as the omnidirectional antenna. And see this perpendicular axis. What is the difference between omnidirectional antenna and directional antenna? Directional antenna means what? Power radiate in specific direction. Power radiate in specific direction. And omnidirectional antenna. Omnidirectional antenna means what? Power radiated in specific direction with respect to perpendicular axis. Means what? See this. Power can be radiated here in this particular area. See this indicated the arrow. In this region only power can be radiated. In this region power cannot be radiated. See this. So it is known as omnidirectional antenna with minor lobe. So it can be considered as a omnidirectional antenna, concept of omnidirectional antenna. Now half power beamwidth, first null beamwidth, side lobe level, front to back ratio. See this, based on that, definitely 2 or 3 MCQ that can be asked. Now see, with the help of whiteboard, we have discussed what is the meaning of half power beamwidth. Half power beamwidth means half power beamwidth means see this. This is minor lobe. This is also minor lobe. This is backlog. This is side lobe. Now, what is the meaning of maximum power radiated? It is known as E theta. It is known as E theta. It considered as a maximum value. It considered as a maximum value. So below 3 dB, if any human person say that if any human person if speak the any particular information or listen any particular information, then sound quality below 3 dB means any person want to listen the song at the 70 dB and other person want to listen the song at 67 dB, then there is no difference in information between 70 dB and 67 dB. What I am trying to say, if 3 dB difference of sound is present, then there is no losses of any particular sound quality. So it is the concept regarding that. So if you can move down below 3 dB, write down here 3 dB, write down here 3 dB. So what is the meaning of 3 dB? Here left side, here it can be considered as the right side. So angular distance between angular distance between 2 points on the antenna pattern. See, this is antenna pattern. See, this is left side, this is right side. The angular distance between 2 points on the antenna pattern, main lobe that are 3 dB below to the maximum point. It is known as half power beam width. Theta HP left minus theta HP right. In direct examination, MCQ can be asked like that. Direct examination, MCQ can be asked like that. What is the equation of HPBW, half power beamwidth? Theta HP left minus theta HP right. This is the equation of half power beamwidth. Please prepare this equation very carefully. Please prepare this equation very carefully. Now, next point, which can be considered as a first null beamwidth. First null beamwidth, it is defined as angular distance between 2 points on each side of major lobe where radiation drops to 0. Means what? Below 50%. Here also 50% is present. Here first radiation. See this, I have sketched the figure. See this. If here first radiation, here power is 0. Here also power is 0. So what is the distance between them? What is the angular distance between them? It is known as first null beamwidth. It is known as first null beamwidth. And it is known as first null beamwidth. So half power beamwidth is equal to half power beamwidth is equal to half power beamwidth is equal to 2 multiplied by first null beamwidth. See this equation. Half power beamwidth multiplied by 2 is equal to first null beamwidth. So it is known as first null beamwidth. Side lobe level, it is known as uh, peak value of the main lobe, minor lobe to major lobe. It is known as side lobe. Front to back ratio already discussed. Power radiated in desired direction divided by power radiated in opposite direction. Now, directivity, gain, and radiation efficiency. It is the most important. Relation between directivity and gain is also important. What is the symbol of notation of directivity? It is denoted by D. It is denoted by D. What is the What is the equation? What is the denotation of K? K equal to radiation efficiency. It is denoted by K. It is denoted by G. What is the relation between gain, directivity, and efficiency? G equal to K into D. How it is established that I will discuss in this theory. Now, directivity means what? What is the maximum direction at which antenna can be able to radiate the power? What is the maximum direction at which, see this, if antenna radiation pattern like that, so this is the maximum direction at which antenna can be able to radiate the power. So maximum radiation intensity. What is the radiation intensity? Now, okay, next point. Power radiated from antenna per unit solid angle. See this. This is radiation pattern at each and every point. With respect to this point, at every point angle is changed. See this. Angle is changed. See also here, angle is changed. See this different angle, it is different angle, it is different angle, it is different angle. So power radiated from antenna per unit solid angle, it is known as radiation intensity. So maximum radiation intensity of test antenna divided by average radiation intensity of isotropic antenna. Average radiation intensity of isotropic antenna, it is the concept of directivity. It is the concept of directivity. Maximum radiation intensity of test antenna divided by average intensity of test antenna. It is the concept of directivity. Now, maximum radiation of test antenna divided by average radiation intensity of test antenna. Now, see this is U upon U0. U divided by P radiated upon 4 pi. Power radiated through isotropic antenna 4 pi U divided by P. It is the basic equation. Radiated power equal to U into D ohm, U sin theta, D theta, D phi. Gain of the antenna means what? Input power, maximum power received from given antenna, maximum power received from reference antenna. G equal to P1 by P2. input power divided by received power. Received power divided input power divided by received power. Gain is the unitless quantity. So 4 pi u divided by p radiated. So p input divided by k. So G equal to Kd, which is the relation between gain and directivity. G equal to 4 pi u divided by P input. So P out equal to P input. So it is considered as a gain equal to directivity. Now, efficiency, antenna efficiency is equal to power radiated divided by total input power. Power radiated divided by total input power. It is known as antenna efficiency. So here it is known as radiated power WR, transmitted power, input power. So radiated power plus loss power. Obviously, transmission means what? Radiation plus loss. So it is known as RR plus RL. So it is the final equation of radiation resistance. Based on that, MCQ will be asked. Please prepare for MCQ. Sendfoundry.in, it is the website related to MCQ to solve the MCQ online. So up till now we have discussed in this lecture. Now we have solved the MCQ. What is the understanding from scalar quantity? Obviously, it deals with only magnitude. Vector quantity means what? It deals with direction. Area means what? It considered as a scalar quantity. What is the meaning of antenna? And always above, it is the transceiver device, impedance matching device, sensor of the electromagnetic wave. 6. What is the basic equation of current that can be able to radiate electromagnetic wave for single wire? So this d2z by dt2 that cannot be present here in each single equation. So answer is B. 7th, EM wave produced due to only moving charge with acceleration equal to acceleration. And if wire is curved, bend, terminated, discontinuous. So it is obviously true. EM wave produced due to this particular concept. Power radiated from antenna per unit solid angle, it is known as radiation intensity. It is the true statement. Antenna radiates the spherical waveform. Also, I have discussed in the uh, comparison between antenna and transmission line. Transmission line are avoided to radiate the wave. Yes, radio communication link does not consist of this component. All of the components that can be consist. Classify the antenna based on the aperture, C, A, B both. Classify the antenna based on the gain, all of the above, high gain, medium gain, low gain. Helical antenna, see this is helical antenna. What is the impedance of free space? 377 ohm. It is known as parabolic reflector antenna. Now see all of the parameters should be affected. Diameter of surface, operational wavelength, antenna efficiency. It is factor that can be affected on the gain of the parabolic antenna. C 19. Answer is C. What is the meaning of radiation pattern? Power, graphical representation of power that can be radiated from antenna. A. Answer is. What are the types of radiation pattern? 3. What is the meaning of isotropic radiator? A, B above. Radiate power equally in all direction. It can be considered as a reference antenna. What is the meaning of directional antenna? It radiates the power in specific direction. Now see what is the meaning of null. Answer is B, C, D both. What are the types of propagation? 3 types of propagation. When electromagnetic wave travel from transmitter to receiver, at that time curvature of earth that can be affected. So answer is A. Far field effect of antenna. Answer is B. Based on that, there are the MCQ that can be solved. Another MCQ that can be related to chapter number 16, radio wave propagation. At that time, I will discuss the MCQ. So this is the completion of lecture. Thank you very much. If you have any doubt, then discuss in the WhatsApp or Gmail. Thank you.